Good morning everyone. Today I am from Government Degree College, Bhadrachalam, here to represent Chemistry Jignasa project. Today we want to throw a light on the project entitled A Sustainable Biogas Production. Its evaluation from digestion of cow dung, food waste, organic waste and case study of biogas production in Lord Sri Rama Temple, Bhadrachalam, a green temple initiative. Introduction. Environmental pollution, especially from solid waste, demands sustainable solution. Anaerobic digestion converts biomass into biogas, a clean energy source, unlike pyrolysis and incineration. It avoids harmful byproducts such as leachate and air pollution. This eco-friendly process effectively manages waste while producing renewable energy, making it a valuable option for rural areas. This version further emphasizes the environmental benefits and sustainable nature of anaerobic digestion. Statement of the problem. The topic of solid waste management has been attracting global attention for years. Scarcity of petroleum and coal threatens the supply of fuel throughout the country. India's biogas production is of 2.7 billion cubic meters per year, which is far below its potential, which is of 28 to 49 billion cubic meters per year. India's biogas production can address energy scarcity, improve sanitation, and reduce air pollution. Over to Sakti.
Aim is to convert biodegradable kitchen waste into the biogas, and the study of Green Temple initiative in Rama Temple, Bhadrachalam. Object is to study the generate energy from the different food wastes, to find the eco-friendly disposal methods for the waste, to study biogas production at the Rama Temple, Bhadrachalam Green Temple initiative. Review of literature. Biogas is a mixture of gases consisting methane, carbon dioxide, water, H2S, produced from the raw materials like agriculture waste and green waste. Biogas is a odorless and colorless gas, burns with the blue flames like LPG gas. It is produced from the organic waste. This multi-stage process involves the hydrolysis, breaking down the complex matters. Acidogenesis, acetic acids are formed. Acetic genesis, acetic acids are formed. Methanogenesis, methane production. Biogas is a renewable energy source, sustainable waste management and energy solutions. Over to Akhil.
Research methodology in order. In our college, B students has performed an experiment on biogas production utilizing food waste, vegetable waste and cover. We have taken 6 digesters with various combinations of waste at a metabolic conditions of temperature 30 to 40 degrees Celsius and pH of 7 for 25 days. The various combinations of waste we have taken are 1 kg of cover with 1 liter of water represented as D1, 1 kg of vegetable waste with 1 liter of water represented as D2, 1 kg of food waste with 1 liter of water represented as D3, and a mixture of cover with vegetable waste of 500 grams each with 1 liter of water represented as D4, and a mixture of cover with food waste of 500 grams each with 1 liter of water represented as D5, and a mixture of cover with food waste and vegetable waste of 333 grams each with 1 liter of water represented as D6. We students have also analyzed the case study on biogas production at Rama Temple in Bhadrachalam in biogas plant utilizing food waste, vegetable waste and covering for the months of November and December. Over to Vishnu.
Analysis and findings. We have recorded the values of gas produced from the experiment we have done in our laboratory. From the analysis of the values, we have found that D1, that is cow dung, has produced the most amount of gas with 135 ml, whereas D2 and D3 has produced 90 ml and 108 ml respectively. We have also recorded the values for the co-digesters D4, D5, D6 for a total 25 days with an interval of 5 days, and found that D5, that is cow dung and food waste, has produced the most amount of gas with 285 ml on 15th day, and the production of gas has been reduced from the 15th day. We have also found that D4 and D6 has produced the gas with 132 ml and 240 ml. We also recorded the values from the Rama Green Initiative Biogas Plant for the months of November and December. In the month of November, out of all days, the most amount of gas is produced on 13th November with 18.42 kg, where the digester is fed with 150 kg of food waste, 100 kg of powder, 10 kg of vegetable waste, with a total waste of 260 kg under a metabolic temperature of 37 degrees. In the month of December, out of all days, the most amount of gas is produced on 26 December with 12.88 kg, where the digester is fed with 180 kg of food waste, 150 kg of powder, 20 kg of vegetable waste, with a total waste of 350 kg under a metabolic temperature of 33 degrees. Over to Kameshwar.
Result. The biogas production is hyper-cow dung with food waste co-digestion mixture. Its value is 285 ml. In our temples, the highest biogas production is observed on November 13 and December 26. The values are 18.42 kg and 12.88 kg respectively. Our conclusions are: the study revealed that co-digestion mixture of cow dung with food waste has high down biogas production. Utilization should be encouraged for high volumes of biogas production as well as solid waste management. Suggestions: feasibility for biogas plants in hostels and temples, assessing waste, space and water. Thank you.